Hello and welcome. So we are going to be proving similar triangles. We're going to go through a semi-formal proof of one. So how we do these is we need to know our definitions. We need to know what things mean in order to make the logical next step. So first off, there's three ways to prove similar triangles. You must have angle, 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 side, 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 or side, angle, side. If you have angle, 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 all angles are the same. All three numbers are the exact same number in both triangles that you are looking at, period. Side, 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 all sides must be proportional. So here's a mini example. Triangle number 1, we have 1, 2, and 3. Next one, we have 2, 3, and 4. What proportional sides means, if I were to take one triangle and divide by the sides of the other triangle, the corresponding sides, so smallest side over smallest side, medium over medium, large over large, right? Correspond those sides, you get the same number for all of those divisions. So 2 over 1, 4 over 2, 6 over 3, all of those equal 2. All right, so that's what it means to be proportional. Side angle side is a mix of the other two, where it says the angle must be the same in both triangles, and the sides that you're given must be proportional. Now, the angle we're looking at must be the angle between those given sides. So, for example, on a little triangle here, we have the smaller triangle right there, and the larger triangle is the whole thing. Right? We have side length 1 and side length 2. 1 and 2. Side length 2 over side length 4. So those correspond. And either way, those are equal. 1/2 equals 1/2. That is a true statement. Right? So our two proportions are equivalent. And the angle between those two sides, right? We have this side and this side, which means in order to use side angle side, I must know the angle between them. Okay? Now, how you would formally craft some of these in a proof is you would use some of these properties, these definitions that we have. The first one is an obvious one, but hard to use or hard to recognize. The first is called the reflexive property, and that's something that says 4 equals 4. You would use this in a case like this, where I need to formally state that the angle for both triangles is the same, because the angle in the smaller triangle is up there. What's the same angle to use in the larger triangle, and how do I know those are the same? Because it's the same object. And the reflexive property is the thing that lets you say that, where it says, if this was angle, I don't know, let's say that was A right there, angle A is congruent to itself because that's what the reflexive property says. If it's the same object, you can say it's congruent to itself. It's a bit of a weird thing to say, and it's obvious, but it does have its own name. Now, the next is the transitive property that we just used to say that our proportions were the same. We got the proportion of our two different side lengths equals the proportion of another two side lengths, right? And they both equaled 1/2. The first proportion, right? Proportion 1 equals proportion, or equals 1/2, sorry. Proportion 2 equals 1/2, which means my proportion 1 equals proportion 2. That is the transitive property. So if I'm using side, 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 or side angle side, you will use the transitive property to prove, right? In your formal definitions, you're going to be saying by the transitive property, my proportions are equal. Okay? That's what that next one means. Now, the definition of similar triangles is another kind of obvious one a little bit, but it's very helpful. And that essentially says that if you have similar triangles, then the sides must be proportional. Okay? Because we prove similar triangles by proportional sides. And this goes both directions. So if you have proportional sides, then you have similar triangles, which is what those two side, 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 side angle sides are doing. Or vice versa. If you know that it's a similar triangle, then you also know it's proportional. Okay, and we'll use or come with the idea of where to use this in the proof we're about to do. And the last one is the angle sum theorem, which is all interior angles in a triangle add up to 180 degrees. The triangle angle sum theorem is what that one says. Okay, that's all kind of your definitions. Now let's figure out how to use them to formally kind of go about a proof. When we're looking at this, we're given a few things. First off, we're given AB with these two lines to DF. That means parallel. That means that we have parallel lines from AB and DF. Okay, so down below, we see it filled in for a statement. AB is parallel to DF. How do we know that? Well, it was literally given to us. Now, the next one, we can see that it's also given to us. What else are we given? Well, we're told that angle CAB, is that little portion right there, is congruent to CDF. So we're told that those two are the same thing, the same number, the same angle. So if that was 20, this is also 20, kind of a thing. So all we're going to do is in my box here, I'll say angle CAB is congruent to angle CDF. That's all I'm going to select there. Now the next one says to talk about angle BCA and FCD. That is going to be these two angles right there. How do we know those are congruent angles? Well, there is some parallel theorems that hopefully you've learned before. We have vertical angles, where if I have an intersection point, the angles on the opposite side of that intersection are congruent, which is what we're looking at here, right? These are vertical angles. And because we have parallelism, I'm actually going to talk about the other three as well. So the next one we're talking about is angle CBA and CFD. So that'll be, use another color, this corner one and that corner. How do we know those last angles are the same? Well, because we have parallel lines, we can use those to help prove that final angle. There's actually quite a few things we could do. So we have corresponding angles. You have alternate interior and exterior angles. Right? So a corresponding angle essentially says that if I have a transversal cutting two parallel lines, right, that top left and top left would be congruent. That is a corresponding angle. So if we knew these were parallel, you would have corresponding angles there. So that would be a use for corresponding. Alternate interior and exterior. Exterior means outside, interior means inside. So when we're looking at these, my transversal and parallel lines, the exterior angles would be outside of the parallels, but alternate sides of the transversal. That is an example of exterior. Interior, we'll talk about things that are inside the parallel lines, but alternate side of the transversal. And that is what we have here. Because if you can imagine that here's my parallel line, here's my parallel line, and then I have my transversal running through those, we want to know about angles B and F. Right, that's the last thing to mention here. Now, your transversal could also be this one here, could it not? Well, is that angle and that angle inside the parallel lines alternate sides of the transversal? Yes, those could be alternate interior angles. Likewise, if that was your transversal, you could say that these are alternate interior angles as well. So that works to find this last piece here. So alternate interior angles. Now, another way we could have guaranteed that last angle is that we already knew 2 out of the 3 angles, right? We were told that we had the blues. We proved the reds by vertical angles. You can actually use your triangle angle sum theorem to guarantee that third angle as well. So if you didn't have parallel sides, you could get that last angle by using the triangle angle sum theorem. Okay, that could be a reason why you would have that third angle. All right, so now we look at the next one. It says triangle ABC is similar to triangle DFC. Well, how do we know these triangles are similar? Well, there's only three ways to prove similar triangles: angle, 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 side, 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 or side, angle, side. Now, we didn't have any sides given, which means the proof we just went through was an angle, angle, angle. And that is your reason. How do you know that these triangles are similar? Because the three angles we just proved are congruent. Right? We just proved we had three congruent angles, which is why we have similar triangles, by angle, angle, angle similarity. Now, the end goal here is to prove this thing. What the heck does that mean? Well, BC is this line. CA is this line. So it's going to be kind of like that. I'm not going to say hypotenuse because we don't know it's 90 degrees, but that longer diagonal side of the triangle to one of the straights, right? Comparatively to FC, that diagonal on the triangle to the straight, these are proportions, right? We're taking two sides of a triangle and dividing them out, which means that you are proving proportional sides. And you might wonder, how on earth am I going to prove proportional sides? Because I don't even have any side links. Well, that is your definition of similar triangles. That's why it's useful that it goes both directions. If you have similar triangles, then you have proportional sides, even if you don't know any of the lengths. So that means that the thing I'm trying to prove, that's my statement, right? What I'm trying to state, what I'm trying to prove. So BC over CA equals FC over CD. I'm trying to prove that. So that's what goes there. And the reason why I can say that my sides are proportional is by the definition of similar triangles. Because we have similar triangles, what we just stated on the line before, we can then say that those sides are proportional. All right, so make sure you're using these definitions to your advantage. You have to know what they mean in order to use them. If I'm going through a side, side, side proof, then my goal is to go for those proportional sides. You will use the transitive property to state that they're equivalent, because that's what you need for side, 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 is equivalent proportions, right? Keep an eye on what you're using. Keep an eye on what you're trying to do. What you're proving is on the left. Your goal is to prove that thing that it tells you. That should always be your last answer. And then your given is typically in front, but it could be mixed somewhere in between. All right, thanks for watching.